Good day, viewers at home. My name is Mr. Major. You are welcome to Mathematics Lab with Mr. Major. Today, we'll be looking at the laws of indices. Now, to begin with, when we talk about indices, the word indices is actually in a plural form. The singular form of indices is index. This is the singular form, index. Now, when we talk about indices, it is a short way of writing multiplication expressions. Let's take, for instance, you have something like A times A times A times A times A times A. We have A multiplying itself, according to what we have here, 6 times. Now, a short way of writing this is A raised to the power of 6. It saves time and it also saves book. Imagine you are multiplying A by itself up to 50 times. That would have probably taken the whole of the board. But you can simply write it as A raised to power 50. Now, this 6 here is what we call index. You can also call it exponents, and you can also call it power. Then the A is the base. This is the base. So if, for example, we have something like 5 raised to power 7, that means 5 multiplying itself 7 times. The 7 is the index or the power or the exponent, while 5 here is the base. So our focus today is going to be on the laws of indices. Basically, we have 6 laws of indices. I will be looking at the 6 laws today. The first law we are looking at is the product law. The product law is also known as the multiplication law. The multiplication law. What is this product law? The product law states that if the bases of a multiplication expression are the same, then you add the powers. Let's take, for example, you have something like A raised to power 5 times A raised to power 3. A raised to power 5 times A raised to power 3. The base here is A. The base here is also A. Because the bases are the same, we just add the powers together. So that will be A raised to power 5 plus 3. And 5 plus 3 will give us 8. That means our answer here is A raised to power 8. This is the product law. Provided the bases are the same, just add the powers together. I would like to explain this law with what most of you are probably used to. Usually, if you have A raised to power 5 times A raised to power 3, you know A raised to power 5 means A times A times A times A times A. This is A into 5 places. Then times A times A times A into 3 places. Now, when we join everything together, that will be A times A times A times A times A times here A times A times A. So we now have 1, 2, 3, 4, 5, 6, 7, 8, which is A raised to the power of 8. So instead of going all through this long process, you can just apply the first law of indices, which is the multiplication law. Now, the second law we will be looking at is the quotient law, which is also known as the division law. The division law is like the opposite of the product law. This law states that provided the bases are the same, we subtract the powers. I will use the same instance I used in the first law. A raised to power 5 and A raised to power 3. So this time around, let's look at division. A raised to power 5 divided by A raised to power 3. Because the bases are the same, all you need to do is to subtract the powers. So that will be A raised to power 5 minus 3. And 5 minus 3 will give you 2. That means our answer is A raised to power 2. That is the answer. Again, I will explain it with the conventional method. Usually, a raised to power 5 divided by a raised to power 3 is the same thing as a raised to power 5 over a raised to power 3, which will be a times a times a times a times a, which is the a raised to power 5, divided by a times a times a, which is the a raised to power 3. So here, a will cancel a will cancel a will cancel a. We are left with a times a, which is equal to a raised to the power of 2. So instead of using this conventional method, the second law of indices makes it very short. We will be looking at some questions, but I want us to finish the first 4 laws. Now, the third law I want us to look at is the zero index law, or you can call it the zero power law. Remember, I told you that another name for index is power, and another name again is exponent. So you can use them interchangeably. Now, what is the zero index law? The zero index law states that any quantity that is raised to the power of 0 is equal to 1. What that means is that a raised to the power of 0 is equal to 1. 5 raised to the power of 0 is equal to 1. 7 raised to the power of 0 is equal to 1. Any quantity raised to the power of 0 is equal to 1. Let me explain this with the conventional method. Supposing I have something like a raised to power 3 divided by a raised to power 3. That will be a raised to power 3 over a raised to power 3, which is equal to a times a times a over a times a times a. Now, a will cancel a will cancel a will cancel a. Mind you, if you have 5 divided by 5, 5 cancel 5 is 1. So, a cancel a is 1, a cancel a is 1, a cancel a is 1. That means our final answer is 1. Now, that is the conventional method. Now, let me use the second law of indices to explain this. In the second law of indices, which is the division law, a raised to power 3 divided by a raised to power 3 is equal to a raised to power, because the bases are the same, that becomes 3 minus 3, which is equal to a raised to power 0. So if 3 minus 3 is equal to a raised to power 3 minus 3 is equal to a raised to power 0, it then tells us that a raised to power 0 is equal to 1, because from the second law we have established that this and this are the same. Let's now look at law number 4, which is the negative index law or negative power law. The negative power law states that if a quantity is raised to a negative power, if a quantity is raised to a negative power, it will be equal to its reciprocal, raised to a positive power. Reciprocal raised to a positive power. Now, when we talk about reciprocal, for example, if I have something like 5, the reciprocal of 5 is 1 over 5. The reciprocal of, let's say, 8 is 1 over 8. Now, the reciprocal of 1 over 7 is 7, or 7 over 1. The reciprocal of 1 over 9 is 9. The same thing, the reciprocal of 2 over 3 is 3 over 2. The reciprocal of 4 over 5 is 5 over 4. So if this quantity is raised to a negative power, you take the reciprocal and raise it to a positive power. That is what the negative power law is telling us. A raised to power minus 1. That means we take the reciprocal of A, which is 1 over A raised to power 1. But take note, A raised to power 1 is the same thing as A. So there will be no need including that one. If we have A raised to power minus 3, that will be the reciprocal raised to a positive power, which will be 1 over a raised to power 3. Now, what if we have something like this? Let's say 3 raised to power minus 1. That would be 1 over 3. 2 raised to power minus 5 will be 1 over 2 raised to power 5. Now, let us look at other fractions. Supposing I have something like 2 over 5 raised to power minus 1. That will be equal to the reciprocal of 2 over 5 is 5 over 2. So that will be 5 over 2 raised to power 1. Like I said, if the power is 1, there is no need writing it. Now, if I now have 2 over 5 again, raised to power maybe minus 3, that will be the reciprocal of 2 over 5 is 5 over 2. So that will be 5 over 2 raised to power 3. Because this is not 1, so we need to attach the power. Now, this power affects everything in the bracket. So that means it's the same thing as 5 raised to power 3 over 2 raised to power 3. Let me pause here and come back here. Look at this, 5 raised to power 3, 2 raised to power 3. But I didn't do that here. That does not mean it's not working here. It is working, but what happened is that this is supposed to be 1 raised to power 3 over a raised to power 3. But why I didn't attach it here is because 1 raised to power 3 is still equal to 1. Because 1 raised to power 3 means 1 times 1 times 1. And that is still equal to 1. So that is why I just attached it to the denominator. That was the same thing that happens here. But if the numerator is not 1, that means you must attach the power, as in this case here. So that means our final answer here, 5 raised to power 3 is 125. 5 times 5 times 5. While 2 raised to power 3, which is 2 times 2 times 2, is 8. And of course, you can change this to a mixed fraction. If we change this to a mixed fraction, 8 divided 12 is going to give us 1, and we'll have a remainder of 4. We bring it here, that will become 45. We have a remainder of 4 from here, bring it here, that becomes 45. And 8 divided 45 will give us 5, and we will have a remainder of 5. That is 15 whole number, 5 over 8 as your final answer, if expressed as a mixed number, or if expressed as an improper fraction, 125 over 8. So now, we will now look at some examples before I will look at the remaining 2 laws of indices. Okay, now I want us to show this small biscuit based on the first 4 laws. Yes, I know you will be wondering, where is the biscuit? Mathematics is a simple subject, so I normally call mathematical problems as a small biscuit. So anytime you hear me use the word biscuit or small biscuit, I'm referring to questions that we need to solve. So let us look at the first biscuit here. The first solution. The first one is 5 raised to power 3 times 5. This is falling under multiplication law. Now, I want us to know, I have said it before, if you have a quantity like A, it is the same thing as A raised to power 1. What that means is that the 5 here is the same thing as 5 raised to power 1. So if we now apply the multiplication law, that becomes 5 raised to power, we now add the powers together according to the product law, 5 raised to power 3 plus 1. And 3 plus 1 should give us 4. That means we are having 5 raised to power 4. And of course, if you simplify, if you find the value of 5 raised to power 4, it's going to give you 625. That means 5 times 5 times 5 times 5, which is 625. That is the answer. Now let us look at the second biscuit. 9 raised to power 7 divided by 9 raised to power 5. 9 raised to the power of 7 divided by 9 raised to the power of 5. This is division, so we apply the division law. The bases are the same. So that will be 9 raised to power 7 minus 5. 7 minus 5. And 7 minus 5 will give us 2. That means 9 raised to the power of 2. And 9 raised to the power of 2 means 9 times 9, which will give us 81. That is the answer. We shall now move to the third one there, which is 27 raised to the power of 0. Remember, I said earlier that any quantity raised to the power of 0 is equal to 1. So there is nothing to solve here. You just place 1 as your answer. Please, let me say this. If there is anything you do not understand, feel free to ask your questions in the comment section. Just drop your questions in the comment section, and I can assure you that I will be responding to all your questions. We will now move to the D. The D question is 6 raised to the power of minus 3. This is negative index law. And remember, I said the negative index law it states that a quantity raised to a negative power is equal to its reciprocal raised to a positive power. The reciprocal of 6 is 1 over 6, then raised to power 3. Like I said, these 3 affect both the numerator and the denominator. So we have 1 raised to the power of 3 over 6 raised to the power of 3. But because I said 1 raised to any power will still give us 1, there will be no need writing this. But if you choose to write it, you are still correct. Then finally, our answer will be 1 over 216. Because 6 multiplying itself 3 times will give us 216. That is the answer to the D. Now the last question here. 3 raised to power q minus 1 times 3 raised to power 1 minus q. Let me quickly establish that q minus 1 here is the power, and 1 minus q here is also the power. So the bases are still the same, 3. So that means multiplication law will be applicable here. So that will be 3 raised to power q minus 1 plus 1 minus q, because according to multiplication law, we should add the powers. So that will now be equal to 3 raised to power q minus 1 plus times 1 is plus 1 plus times minus q is minus q. So now this is equal to 3 raised to power. Let us group the like terms. So q and minus q, they are like terms. So I bring them together. Then minus 1 and plus 1 are like terms. Now let us simplify. This will be 3 raised to power. Q minus q is 0, so that is gone. Minus 1 plus 1 is also 0. So everything is now 3 raised to power 0. And again, anything raised to the power of 0 is 1. That means our final answer here is 1. Okay, now we will be looking at the remaining laws of indices, the 5th and the 6th law of indices. All right, let us look at law number 5. That is the power law. Now, the power law is something like this. If you have a raised to power 7, then enclosed in a bracket, and then raised to power 3. Now, if you have an algebraic expression like 2 into bracket 5 plus x, we know that this 2 multiplies everything inside the bracket. That will be 2 times 5 is 10 plus 2 times x is 2x. The same thing will be applicable here. However, we must know that this one is a power. It is an index. It's not a base. So it does not multiply the base. It rather multiplies the power. Power multiplies power. So that means it will be a raised to power 7 multiplied by 3. And 7 multiplied by 3 is 21, giving us a raised to power 21. So the power law says that the power inside the bracket multiplies the powers inside the bracket. Now, I want to explain the power law with another question. If you have something like this, let's say x, y raised to power 3 enclosed in a bracket raised to power 4. In this case, this 4 will affect both the power of y and the power of x. So this will be x raised to power. Remember I said a quantity that is written just like this means the power is 1. So this is actually x raised to power 1, then multiplied by the power outside. That will be x raised to power 1 times 4 times y raised to power 3 times 4. So you see that the power outside the bracket is multiplied the powers of both x and y. Let's remember xy is the same thing as x times y. That is where my multiplication sign is coming from. So what that means is that we have x raised to power 1 times 4 is 4, and then y raised to power 3 times 4 is 12. And this becomes the final answer. Now let us look at the fractional index law. This is the last law of indices we'll be looking at. The fractional index law. If we have something like, let's say, a raised to power half. When you have a fractional index, like this one that is half, a raised to power half, this denominator is always regarded as root. This is root. So if it is half, since the denominator is 2, it means square root. It means square root. If it is a raised to power 1 over 3, that will be cube root. That will be cube root. So if it is a raised to power 1 over 4, that will be the fourth root. The fourth root. If it is a raised to power 1 over 5, it will be the fifth root. So what that means is that a raised to power half is equal to the square root of a. Now, a raised to power 1 over 3 is equal to the cube root of a. A raised to power 1 over 4 is equal to the fourth root of a, and so on and so forth. Let me explain with numbers. Supposing we have something like 4 raised to power half. It means the square root of 4, and of course the square root of 4 is 2. So the answer is 2. So if I have something like, let's say 169 raised to power half, that means the square root of 169. And of course the square root of 169 is 13. You can actually do this in another way. So let's say 4 raised to power half. Since the denominator is 2, you can look for a number that can be raised to the power of 2, and the answer will be 4. And that is 2. 2 raised to power 2 is 4. So another way of writing 4 is 2 raised to power 2. Then times the power that was already there, half. Here, 2 will not cancel 2. You are left with 2 raised to power 1. And of course, 2 raised to power 1 is 2, which is the same answer as this. The same thing, you can also do something like this here. 169 raised to power half. 13 raised to power 2 will give us 169. So we write 169 as 13 raised to power 2 times the power that was already there, half. Again, 2 will cancel 2. You are left with 13 raised to power 1, which is still equal to 13, as we have here. Now, let us look at this question. Here, the numerator is no longer 1. Now, as we know, the denominator is regarded as root. So if you have something like a raised to power 5 over 7, this is regarded as root, like I earlier said. Now, the numerator is regarded as power. Mind you, the whole of this thing is actually power. So if we have something like this, it means the cube root of 27 then raised to the power of 2. That is the meaning. Cube root of 27 raised to the power of 2. The cube root of 27 is 3, because 3 raised to power 3, that is 3 multiplied 3 times, will give us 27. So the whole of this is turning to 3, then raised to power 2. And of course, 3 raised to power 2 is equal to 9. Again, you can use the second method I used for the previous ones. That means 27 raised to power 2 over 3 is equal to, you look for a number which when multiplied by itself thrice, 3 times, will give you 27, since the denominator here is 3. And that number is 3. 3 raised to power 3 is another way of writing 27. Because this is equal to 27. Then times the power that was already there, 2 over 3. Here, 3 will cancel 3. You are now left with 3 raised to power 2. Again, 3 raised to power 2 is equal to 9. Now, let us look at this question on the board. The first one here is 4 raised to the power 3 and then raised to the power of 2. By the power law, this will multiply this. So that means we have 4 raised to power 3 times 2. 3 times 2 is 6. That means our answer is 4 raised to power 6. That is the answer. Then for the second one, we have 32 raised to the power of 1 over 5. Now, what can multiply itself 5 times? Since the denominator here is 5. What can multiply itself 5 times to give us 32 is 2. So that would be 2 raised to power 5. Then times 1 over 5. So here 5 will cancel 5. We are left with 2 raised to power 1. And 2 raised to power 1 is equal to 2. Of course, you can still do it like this. 32 raised to the power of 1 over 5 means the 5th root of 32. And that is still 2 because 2 raised to power 5 is 32. Now, let us look at the third one. The third one is 64 raised to the power of 2 over 3, which is what can be raised to the power of 3, since the denominator here is 3. What can be raised to power 3 to give us 64 is 4. So that means 4 raised to power 3, then times 2 over 3. Here 3 will cancel 3. We are now left with 4 raised to the power of 2. And of course, 4 raised to the power 2 is equal to 16. So our answer here is 16. Alternatively, you can say 64 raised to the power of 2 over 3 is equal to the cube root of 64, then raised to the power of 2. Cube root of 64 is 4. So that means 4 raised to the power 2, which is equal to 16. So you can do it like this or like this. Question 4 is 0.001 raised to the power of 3. We must first of all change this to fraction. 0.001 is the same thing as 1 over 1,000. So that means 1 over 1,000 raised to the power of 3, which is 1 to power 3 over 1,000 to power 3. That means our final answer, 1 raised to power 3 is 1. And then 1,000 raised to the power of 3 will give us 1 billion. That is this. That is 1,000 times 1,000 times 1,000. And this will be your answer, 1 billion. The next one is 5e raised to the power of 2, then raised to the power of 3. So that will be 5 raised to power 1. Since it's like this, the power is 1. Times will be multiplied by the power outside times 3. Then times e raised to the power of 2. And then times 3. Which will give us 5 raised to power 1 times 3 is 3. And then 2 times 3 is 6. That is 5 raised to power 3, e raised to power 6. Let us find the value of 5 raised to power 3. That is 5 times 5 times 5, which will give us 125. Then e raised to power 6 as the final answer. The next one is question number 6, which is 9 raised to 0.5. This is the same thing as 9. We need to change this decimal to a fraction. 0.5 means 5 over 10. And this can be reduced. If you reduce it to its simplest form, 5 divided 5 is 1. 5 divided 10 is 2. That is 1 over 2. So this is 9 raised to power 1 over 2. Of course, this is now, since the denominator is 2, that means is the square root of 9. And the square root of 9 is 3. You can also do it this way. Since we have 9 raised to power 0.5 as 9 raised to power half, you can look for a number which one raised to power 2, since the denominator is here 2. The number that can be raised to power 2 to give you 9, and that is 3. So we have 3 raised to power 2 times the 1 over 2. So here 2 can cancel 2, then 3 raised to power 1 is still equal to 3, which is the same answer as this. 0.125 raised to power 1 over 3. Raised to power minus 1 over 3, please. Now, let's first change this to a fraction. If you change 0.125 to a fraction, that is 125 over 1000. You can use it like this, and of course, you can reduce it to its simplest form. If we reduce this to its simplest form, 125 can go into 1000. 125 into 125 is 1. 125 into 1000 is 8. So you either use the 125 over 1000 or 1 over 8, and you will arrive at the same answer. So let me use the simplest form. So this is equal to 1 over 8 raised to power minus 1 over 3. Now, you will recall that I said any quantity raised to a negative power is equal to its reciprocal raised to a positive power. The reciprocal of 1 over 8 is 8 over 1, and 8 over 1 is the same thing as 8. That means the reciprocal here is 8. Then raised to a positive power, which is now 1 over 3. That means we are looking for the cube root of 8. The cube root of 8 is 2, because 2 multiplied itself 3 times will give you 8. That means our final answer is 2. Of course, if you don't want to handle this place this way, you can continue like this as 2 raised to power 3 times 1 over 3. Since 2 raised to power 3 is another way of writing 8, then this will cancel this. Then 2 raised to power 1 is still equal to 2. So you either do it like this or like this. You have the same answer. Okay, we have another question, number 8, which is 16 over 54 raised to power minus 1 over 3. This is going to be the reciprocal raised to a positive power again. That means 54 over 16 raised to power 1 over 3. Reciprocal of this raised to a positive power. Now, there is no number that can multiply itself 3 times to give you 54. And there is no number that can multiply itself 3 times to give you 16. That means these numbers does not have cube root. So what we need to do is to reduce them. Look for a common factor that can divide them. 2 can divide both numbers. So let us divide. If 2 divide 54, we have 27. If 2 divides 16, we have 8. So that means we are now having 27 over 8. 27 over 8 raised to power 1 over 3. Now, both of them have cube root. So that means we are now having cube root of 27 over cube root of 8. The cube root of 27 is 3, because 3 multiplies itself 3 times will give you 27. And the cube root of 8 is 2, because 2 multiplies itself 3 times will give you 8. That means our final answer is 3 over 8. Of course, you can express this as a mixed fraction. That is a mixed number, which will be one whole number, 1 over 2. Question 9 is 7m raised to power 3 times 2m raised to power 5. Now, let's look at this. The base here is 7m. The base here is 2m. They are not the same. But let's go back to algebra. If you have 7m times 2m, you know it's the same thing as 7 times m times 2 times m. That means 7 and 2 will come here. 7 times 2, then times m times m. So if we apply this, that means we are going to have 7 times m raised to power 3 times 2 times m raised to power 5. So we are now having 7 and 2 are like terms. So we have 7 times 2, then times m raised to power 3 times m raised to power 5. Now here, 7 times 2 is 14. Then for this one, the bases are the same. So we apply multiplication law, which is law number 1. That would be m raised to power 3 plus 5, because multiplication law says we should add the powers. That means our final answer is 14m raised to the power of 8. That is our final answer. We will look at the last biscuit for today. Now, the last biscuit, number 10, is 18x raised to power 3 divided by 3x raised to power 2. This is the same thing. See, we take the numbers first. So that would be 18 divided by 3. Then times x divided x raised to power 3 divided by x raised to power 2. The powers, okay, let me just take it. X raised to power 3 divided by x raised to power 2. This is now 18 divided by 3 times x raised to power. Since this is division, we apply division law, which means that we should subtract the powers. That becomes 3 minus 2. So 3 divide here, 3 divide 3 is 1, and 3 divide 18 will give us 6. That means our final answer is 6. X raised to power 3 minus 2 is 1. So 6x raised to power 1 is our final answer. But remember I said if the power is 1, there will be no need writing it. So we leave it as 6x as our final answer. Okay, so this is here we will be stopping our class today. I have given you some biscuits to chew. I told you that mathematics problems are very easy, so I call them biscuit. So I'm leaving you with this 12 biscuits to chew. You can drop your answers in the comment section. Let me see the first person that will be getting the correct answers to all the 12 questions. The first person to get the correct answers to all the questions will be given a prize. So do not forget to drop your answers at the comment section. Please, if you've not subscribed to my channel, kindly subscribe. If you are watching me from Facebook, follow my page. If you are watching me from YouTube, subscribe to my channel, like my video, share it, and do not forget to come back to this channel because I'll be dropping videos on every topic. Every topic. Let me also say this, that now that we have finished the laws of indices, the next thing I will be discussing is exponential equations. That is equations based on the laws of indices. It's called indica equations. So please, just try this biscuit. Put the answers in the comment section. The first person to get the answers to all 12 questions correctly has a prize.